Hello and welcome to Chapter 5 and Statistics 1. Yes. So we are going to talk about the discrete random variable. So this is a chapter on discrete random variables. We're going to take a look at some casino games and the odds of winning the lottery and things like that. The fair die versus the unfair die, and trying to get the odds in your favor and so on. So to understand these concepts, we have to have few definitions first. So generally in the first section, that's what we do. So let's start with a random variable. Is a quantitative variable whose values depend on chance. So a random variable is a quantitative variable whose value depends on chance. So that's what the random variable is. And now we get to be more specific and say discrete random variable because we can list the outcomes, right? So discrete random variable is a random variable whose possible values can be listed. So go on, walk into a neighborhood, and then pick a variable and go door to door, get your data. Hi, how many TVs do you have in the house? And they say 3. 3. And you walk next door. How many TVs do you have? 4. 4. So go next door. Hi. How many TVs do you have in the house? 1. Good. Right? So you see, you can't have 3.5 TVs. Right? It's a discrete. You either have 0, 1, 2, 3, 4. And you are not going to run into a house that will say 19. Right? Because it's technically a warehouse at that point. So, and you would recognize the warehouse from the house. It doesn't have drapes in the window. That's how you know. Some houses in New York are very difficult. Pick apart from a warehouse. So what is that? We can say number of TVs per house. Because it's totally the chance. It's random, right? Sure, when you live in that house and you say, okay, I need 1 for the living room, I need 1 for the family room, and I need 1 for the basement and 1 for the bedroom, let's say, that's 4, right? There you go. So it's not random for you. But for me as a researcher who goes door to door, the number of phones, the number of computers, the number of children, right? It's not arbitrary for you. You would say, I want 0 kids, I want 3 kids, I want 2 kids, right? So that's not random for the family experiencing it. Or maybe it is. I don't know. But it is random in my view, because when I walk to a house, I don't know what I'm going to see there, right? It's not prescribed if you live let's say in Somerville, you must have 3 TVs and 2 children, otherwise you don't get to live in Somerville, right? That's not a rule. So it's by chance, any of those. So that's why all of these things now become random variables. I can list their outcomes. You can have 1, 2, 3, 4, 0 TVs. Same thing with children. Same thing with computers. Same thing with cell phones and regular phones. Or number of pans, right, to fry things in the house. It's all, right, the same stuff. So that would be it. And the random variable will have the notation. That's going to be also red. Notation is lowercase x for the variable. So I would say x is the random variable, x is the, what do you call it? Number of TVs, or so number of TVs per household, or children, or whatever. And then we are going to have the probability to select. So P of x equals x is probability that the random variable x equals x. Now this is a little bit tougher to understand without examples, so let's jump into it. Probability distribution is the list. Let me write those as well. So probability distribution so they have sentences and words and everything. I'm just going to say it's the chart of all values, chart of values. Right, so your frequencies and probabilities are given, right? That's the chart. And then you have probability histogram, which is a graphical representation. So probability histogram, a graph of distribution. So distribution is just a chart. Let me give you immediately. So they're saying the number of siblings. Okay. So number of siblings. They give you the chart, and this chart is known as the distribution, probability distribution. So siblings. And that's x. And this is the probability of those siblings occurring. So 0, 1, 2, 3, and 4. And this is 0.2. 20% no siblings. See that? Then you have 0.425 for one sibling, 0.275, 0.275, 0.275 for total probabilities, obviously, to add to 1. This thing over here is called the probability distribution. This list. So now I can ask, what is the probability that a person has 2 siblings. Your answer? 0.275, yes, 27.5%. That's that. So it's extremely easy to read. Probabilities are given, you just look at it and you know. Also note that the sum adds to 1. So sum of all probabilities is 1. Because this is it. We surveyed everyone and no one had 5 siblings. That means there were no families with, let's say, 6 kids, right? Because to have another 5 siblings, that means you were there and then plus. So that's the 5. This is a single kid, right? Also not included families without kids, right? There we go. So that's what we have. To draw the histogram, you know to draw a histogram. So let's draw the histogram. And that will be it for today. The levels, 0.1, 0.2, 0.3, 0.4, 0.5. So these are the probabilities. Over here on the bottom, we can say 0, 1, 2, it's in between actually. 0, 1, 2, 3, and 4. So this is discrete random variable x. On the first one, for 0, I have 2. Well, see? But it's called experience. Then we have 4, 2, 5. It's 4 1/4. Then 2, 7, 5. And all the others on 2, 7, 5. And that's the histogram. So we'll take a look at more of these exercises. There's some also wording that we need to take care. So next class we'll finish 5.1. We'll go 5.2, 5.3 as far as we can go. We'll be done with chapter 5 this week, which means we can talk about the exam if you're interested in having one. I'll see you all next class.
Chapter 3, right?
Right.
Thank you.
Do you have class right now?
What happened?
Are you going to class?
No, I have a meeting that starts in 10 minutes. I have to run because I'm hosting it.